Okay, let's start chapter 10, and chapter 10 really is pretty similar to chapter 9, but in this case we do have population number 1 and population number 2, so we have two populations. And from each one of the populations, we are going to get a sample. And from that sample, we are going to get x1 bar, x2 bar, and p1 bar, and p2 bar. And x1 bar is the mean of the sample, and p is the sample proportion. And we are going to make inferences about the population parameters, mu1 and p1, that are the mean of the population for the population number 1, and p1 is the proportion of the population from the population 1, and then we also have the population parameters mu2 and p2. Okay, we are basically going to compare the two population means, mu1 against mu2, and we are going to say either if they are equal or greater or less or equal. Okay? Now, since we are doing this, really what we are going to try to do is not if mu1 is equal to mu2, but it's mu1 minus mu2 is equal to 0. So this is exactly the same. Mu1 is equal to mu2 is exactly as mu2 minus mu2. Mu1 minus mu2 is equal to 0. Now, so we will have the null hypothesis mu1 minus mu2 is equal to 0 against the alternative that is not equal. In this case, we will have a two-tailed test. We also may have the null hypothesis mu1 minus mu2 is less or equal than 0 against the alternative that is greater than 0, and this is a one-tailed test, upper tail. And we will also have the null hypothesis exactly the same as is greater or equal than 0 against less than 0, and this is going to be a lower tail test. That's it. We do have different situations in this chapter. The first situation is when we know the standard deviation of the populations sigma 1 and sigma 2. In this case, it's pretty easy. Because of what? Because we use the standard normal distribution distribution in order to make the comparison in these tests. Now, when we do have the standard deviations of the population sigma 1 and sigma 2, we are going to have this situation where it's pretty easy. When we know this, sigma 1 and sigma 2, that again are the standard deviation of the populations, we are going to have the test statistic equal to what? x1 bar minus x2 bar minus d0, and again d0 usually is 0, and is nothing but this number over here. So it can be any number. It can be any number at all, but usually is 0. Divided by what? The standard deviations, sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. That is the formula that you can find in your book on page 411. The formula is 10.5. Okay? And that's it. This is the test statistic, and we are going to compare with, really depends on the type of test that you're looking for. But if you're looking at a two-tailed test, these are the critical values, and you know how to calculate the critical values. If we are dealing with 95% confidence level, the critical values are what? 1.96 and positive 1.96. Those are the critical values, and then you're going to compare this test value against these critical values. If the test value is in the rejection zone, you reject what? The null hypothesis. If it's in the non-rejection zone, you don't reject the null hypothesis. That's it. Also, in this chapter, they are dealing with confidence interval, but it's exactly the same. The confidence interval. What is the confidence interval? x1 bar minus x2 bar plus or minus z of alpha divided by 2 times what? The same thing. Sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. That's it. That's it. You know what is these alphas. Look at table 8.1 on page 313. And those are the z alpha divided by 2, really depending on what? The confidence level for the interval that you're looking for. That's it. That's the first part of the chapter. Let's do one problem. Let's do problem number 5. Okay. Let's do problem number 5. Problem number 5, it says, the average expenditure in Valentine's Day was expected to be $100.89. Now, they have to compare male and female consumers, and they want to know if they really are different with the money they spend in Valentine's Day. The average expenditure in a sample survey of 40 male, so we are comparing male and female. In the male we have N1 equal to 40, so we have a sample size of 40, and the consumption was 135 and 67 cents. And the average expenditure in the sample survey of 30 females, so we have N2 is equal to 30 and X2 bar is equal to 68.64. Okay? Based on past surveys, the standard deviation of the male consumers of sigma 1 is equal to 35 and sigma 2 is equal to 20. So we do have the standard deviation of the populations, okay, for the male population and the for female populations. Now, good. What is the point estimate of the difference? The point estimate is x1 bar minus x2 bar, and that is equal to 135.67 minus 68.64, and that is equal to, okay, 135.67 minus 68.64, and that is 67.03. That is the point estimate. Okay, B, a 99 confidence interval. Okay, they want us to find the 90% confidence interval of the difference on the difference with the expenditures between the males and female. Now, what is the 99% confidence interval? Is x1 bar minus x2 bar plus or minus c of alpha divided by 2 times sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. That's it. So it is 67.03, that is the point estimate of this, okay, plus or minus E of alpha divided by 2. What is the 99? Okay, go back to table 8.1. For the 99 confidence level, we will have C of 2.576. 2.576 times 35 squared divided by 40 plus 20 squared divided by 30 and everything square root, and that is 35. 40. 20 squared divided by 30 square root times 2.576 is equal to 67.03 plus minus 17.08. This is my confidence interval for the expenditures in the difference between male and female. That's it. That's it. Okay. Now, this is for confidence interval. The only thing here is be very careful that you square the standard deviation, because we are dealing with the standard deviation over here. Look at the formula. This formula is very easy to confuse, but just follow the recipe and then you will have whatever. Okay, this is confidence interval. Let's do one problem about hypothesis testing. Let's do problem number what? 7. During 2003 season, Major League Baseball took steps to speed up the play of baseball games in order to maintain fan interests. These are the following results from the time the games of the Major League Baseball last. Okay? Now, we have in the 2002, we have N1 is equal to 60. Yep. And X1 bar is equal to 2 hours and 52 minutes. Okay, in the next year, season 2003, we have a sample size of 50, and my mean on that sample is 2 hours and 46 minutes. Okay, and they want to, what? First of all, a research hypothesis was that the step taken during 2003 season would reduce the population mean during the games. Formulate the null hypothesis, an alternative hypothesis that really is going to check if there is a significant reduction of time between 2002 and 2003 seasons. Okay, so when we formulate the hypothesis, we need to know what we are looking for. And we are looking for that it's really a reduction. We want to know if really it was a reduction of time for the following season. And then this is what we would like to prove. And this has to be formulated as the alternative hypothesis, because remember that when we reject a null hypothesis, we are accepting the alternative hypothesis. Now, so the alternative hypothesis has to say this particular thing. So it has to say the alternative hypothesis, mu1 minus mu2 is greater than 0, against the null, that is mu2 minus mu1 minus mu2 is less or equal than 0. Okay? So this is how we set up our hypothesis. In this case, we will have a one-tailed test, an upper-tailed test, and we will have, I don't know, what's the confidence level or the alpha is 0.05. Now, basically, so for 0.05, this is what? Go to the table. And remember, this is 0.05, this is 1.645. This is my critical value. Remember, this is 0.05. So my critical value is 1.645. Okay. Okay, the hypothesis is already formulated. What's next? What is the point estimate of the reduction of these, the duration of the games? Okay, we cannot do this as it is. We have to convert it to minutes. So this is really 120 plus 52. That's equal to 172 minutes. And this x2 bar is 120 plus 46. That's equal to 166. Okay? That's really because we convert everything to minutes. So x1 bar minus x2 bar is equal to 172 minus 166, and that is equal to 6. That's my point estimate of the means. Historical data indicates that the population standard deviation of 12 minutes is in both years. So sigma 1 is equal to 12, and sigma 2 is also equal to 12. That's it. Okay. Check the test.